Okay, so this problem says, suppose that 70% of all college women have been on a diet within the past 12 months. Okay, I don't know if I believe that. Um, if we take a sample survey of 267 college women, what's the chance that 75% or more of the women have been on a diet in that last year? All right, so it looks like this problem has to do with proportions because we're talking about 70% up here of all college women, and then down here we're looking at the chance of getting 75% or more of the women from our sample having been on a diet. All right, so it's a proportion problem. This line up here that says 70% of all college women have been on a diet tells me that the population proportion is 70%. So that 70% up here has got to be our theta because it says all college women. All right, so let's write that down. Theta is 0.70. All right, then the other thing here is the sample that we take. And the sample that we take involves 267 college women, so that tells me the sample size for our sample that we're interested in. And then the other thing that they're asking me about here is what's the chance that when I take this sample, I get 75% or more of the women in that sample having been on a diet in the last year. Okay, so let's draw a picture here of the p-hat distribution, and we'll see what's going on. All right, so here's the p-hat distribution, and this is the distribution of sample proportions. And in the middle of this distribution has got to be the population proportions, 0.70. All right, so that's our theta in the middle there. And then this graph represents, what this curve represents is as I take sample proportions, most of the sample proportions will be near that 70%, near the middle, but then occasionally I'll get sample proportions that are out here in the two tails of this distribution as well. So at any rate, this is a normal curve right here, and it's telling me that the sample proportions fall so that they obey a normal curve, a normal distribution. All right, so let's see, what else? So okay, so the 75% is up here. Let's put that in down here. So that's over to the right of 0.70. And it's actually asking me to find the chance that I get 75% or more in my sample proportion, and that's got to be the area to the right of this value up here. All right, so it looks like I want to find this area right here. Now, the way to do that is to change everything into z-scores and work with those and look at the area using a table. All right, so let's put our z distribution over here, the standard normal curve over here, and these are z values. And in the middle of this thing is 0, and that corresponds to the 0.70 over here. And then somewhere over here to the right of 0 is going to be a z value that goes with this 0.75. So that's what I'm after, is that z value. And once I get that, I'll look up the area to the right of that using the standard normal curve. Okay, so let's write down the formula for a z-score. The z-score is going to be data minus the mean all over the standard deviation. All right, and then the data in this case is this 0.75. And the mean, of course, is this value in the middle here, 0.70. And then the standard deviation we don't have, but we can compute. Let's come down here. Standard deviation is going to be this. It's a formula that comes from the central limit theorem, and the central limit theorem tells us that it's the square root of the population proportion, and then 1 minus the population proportion, and then I have to divide by the sample size, 267 down here. Or let's do it this way. Put in here to start with. and then over here. All right, so now let's plug in our values in here. So theta is 0.70, and then the 1 minus that is 0.30, of course. And then down here, the n is 267. Okay, so we got to compute that. So we get, we're going to use a calculator. 0.7 times 0.3 equal this, divided by 267. This. Now we got to take a square root of that. Okay, so I get 0.0280, and it's good to carry about 4 decimal places when you're working with proportions, because remember, you're trying to work with, if you're working with proportions, you're working with percents. So you want to make sure that you don't round off to 2 decimal places, because that will lose some accuracy. So carry 4 and then round at the very end is probably a good idea. Okay, so the standard deviation is that. Let's put it in up here, 0.0280, and then on the top here we have 0.05, and then 0.280 on the bottom. 0.0280. So that's going to be about 1.79. 1.79. So that means that the z-score over here is about 1.79. Okay, now to look up the area to the right of that z-score, we have to do this. I can get the area to the left of that z-value by using the table. So in order to get the rest of it, the area that's over to the right of that, what I need to do is subtract from 1. And so I'm going to take 1 minus the table lookup of that z-value, 1.79. And I'm going to look that up with a table, although you could do it in Excel too. So I need to find 1.79. So I go over to 1.7 and then go over to the 9 column, and I get this 0.9633. Alright, so now take 0.9633 and subtract that from 1, and I get 0.03, 0367. And so if we round that off to the nearest percent, it's going to be about 4%. Okay, so this area up here is 4%, and that tells me that the area over here is 4% as well, and that tells me that I got about a 4% chance in this sample that we took of seeing more than 3/4 of the women having been on a diet in the last year.